Hi everyone, thank you for coming. I'm really happy to see that so many people decided to come here and listen to a very, very simple story. Because this story is my story. I'm Pasha, by the way, and this is my story. I used to use ChatGPT a lot, for almost from the moment of the announcement. I used it for all kinds of things. I laughed at it when it generated nonsense and so on. I mean, I use it for work sometimes too, but I didn't really care about how it works. By the way, timer is not launched here. I didn't care about its internals. Well, I mean, of course I heard neural networks. What's like? I have a psychological education. For me, the brain is the neural network. Like neurons right there, somehow interconnected, axons and so on. I cared a bit though, like on the level of mere mortal, I believe. But I didn't know much about it. And of course, I didn't hear about RAG. Who knows what RAG is? Six, seven of you. Okay, I still can't remember this how this initiation unfolds. That it's retrieval augmented generation. For me, it's just RAG. But, well, yeah. Who is like me here? Who uses AIs and probably doesn't know anything about RAG? Most of you. Nice. So you all are hopefully my audience, and hopefully you will take something useful from this talk. Well, I mean, we'll see. It's not like I will tell you everything and explain everything about neural networks. And I bet you know some stuff, but I will try to cross some T's on topics you probably didn't think about or that were not explained before. As I said, of course I heard about neural networks. Who saw this picture? Yes. Who understands it? Yeah, so this was my question. What the heck is this? I see yellow dots, green dots, and pink dots. Input layer, hidden layers, and output layer. And I believe this is how ChatGPT is supposed to work. Essentially, for me, it's like me, then black box, and it's a very sophisticated diagram, isn't it? Me, black box, output. This is the case of Midjourney generates picture for me, as you can see after the output. And if you look at the architecture of my diagram, it's very much like this architecture. Me as a yellow input, green as black box hidden layers, and output is output layer. So at this point, I should probably tell you something about myself. I work with JVM languages for 15 years or so. I used to be a backend developer, data engineer, engineer manager, and everything in between. It means I actually worked with folks who use LLMs and who create them, who create these neural networks and so on. I worked for training data for them, for data with data sets for them, and still I didn't understand how the thing works. And this is kind of fine. But I also did a lot of performance optimizations for them, even not understanding how it works. But this talk is not about it. Now I work as a developer advocate at Bellsoft, and this is an important part because I have a lot of time to experiment. I know you all have your usual jobs. You have to come at your job, write code, like do something meaningful. I do not. But I need to produce the content. I need to produce the content for the community, and I still love to write code because you just can't stop doing it after 15 years, right? So, by the way, you can follow me. I brag a lot in Blue Sky, Twitter, and so on. So, creating content. To create content related to what Bellsoft does, and Bellsoft does JDK, I have to understand what the hell are we doing in our company. I guess many of you also doesn't know exactly what their product does, with all the small nuances. Oh, I'm the only one. Okay, like 2 of you, 3 of you. Nice. Thank you. Thank you for support. For those of you who do not know but have documentation like we, this talk will be specifically useful. I mean, I would even say instrumental, because we have a lot of content we already created. We have blog posts, we have a lot of documentation, we have white papers we wrote about JDK and so on. And I just couldn't find my way through this documentation. I mean, how do I even start? Because you open the set of white papers and it's like 300 white papers. I can't possibly read them all. And obviously, like, I go to our blog and it's hundreds of blog posts by different people in different style on different topics. Some of them are interesting and some of them are not interesting to me at all. Probably will be interesting to you though. And the same with documentation. And we also have security advisory, which is a completely different set of documentation, which says this was fixed, this was created, and so on. So I needed to do something about it because, again, to create meaningful content, I should understand what we are doing. And I started to look for solutions. And I'm a developer. I'm trying to use instruments I know. For example, I know Elasticsearch. And obviously, if we have a lot of documents, this is what I used to do. Load all these documents, dump all these documents into Elasticsearch, launch full text search over this Elasticsearch, right? And probably, hopefully, get some content out. Or Google Desktop. Who knows Google Desktop? Yeah, you probably need your pain medications for your back, right? Google Desktop is dead, as I discovered when I prepared this talk. There is no more such thing. And also grep. I mean, you can grep a lot of things. Grep is very powerful. Even in PDF documents, it theoretically can grep. You probably will need to add OCR layer to it, but other than that, you can totally grep. But all the solutions have a fatal flaw, I bet. You need to know exactly what you are looking for. And how do you know what you are looking for if it's almost a new product? Well, I mean, I'm a JVM developer for quite some time. Still, I don't know all the things Java. So, who are we developers and what we do? Yak shaving. I didn't like the previous solutions, obviously. This is what I decided. Let's use AI. I should use AI because AI gives me all the meaningful answers these days. But how do I do it? Luckily, I have a friend. It's hard to believe, I know, but well. And he is good friend enough, and he allows me to ask him stupid questions. And the question I asked is, how do I search through my documents? You do this neural networks magic for years, right? And he actually does it for years. He did it 10 years ago, and probably, and 7 years ago for sure. So for a long, long time compared to me. And he's a good friend, so he doesn't try to give me a fish. He tries to teach me how to do stuff. And he asked me, what do I know? And this was something like my answer. Well, I heard about Word2Vec, I heard about layers, like on this picture with green, yellow, and red. I heard about embeddings, and he was like, oh, if you know embeddings, he said, explain me embeddings. And I actually couldn't. So when I said, I know embeddings, I meant actually, I heard this word. And I don't have any idea who knows embeddings? Who knows them better than me? at that moment. Okay, like 4 of you. Nice. So half of this talk will be probably useful for all of you. So you can see a couple of examples of embeddings here. It's just an array of doubles. And what do they mean? I mean, is it possible to look at embedding and understand this embedding stands for daddy, and this is for teddy bear? No, because embeddings doesn't mean anything outside of their particular system and outside of their context, actually. So let's look at an embeddings slightly deeper. An embedding is a way to represent something abstract, It could be a word, a picture, an idea, I don't know, text, a list of numbers as a list of numbers. The simplest way to represent embeddings is if each city in the world would be in exactly some geographical latitude and longitude, we could say that New York is located here and Tokyo is located here. In this way, we could build embeddings for each cities in the world. It would be just two doubles. Obviously, it's slightly more complicated than that. We usually have this convex for cities, and we have a lot of points in there, and it becomes unusable. But the whole idea stands. Coordinates tell us where cities are in physical space. Embeddings tell us where things are in a meaning space. And I know it's very, very philosophical, so let's make it slightly closer to the earth. Cat and kitten would be closer together because they're very, very close to each other in our heads. And cat and rocket are probably very much far apart from each other. They both are material, but this is essentially all. They don't have anything else in common. And I have a small video here. Let me demonstrate it. And they have this nice property. Imagine we have 2 points, king and man, in our meaning space, and it's just in 2-dimensional space, but it's just for simplicity. In real case, it will be probably thousands of them. And we can add these vectors of king and man. They are points, and at the same time, they are vectors, obviously, going from 0. If we deduce man from king, please play. And now we define one more term called woman. We can say that king minus man plus woman equals queen. And this is the whole idea of this meaning space. We can operate on almost unrelated entities like they're vectors in our meaning space. Again, this is only 2 dimensions just because it's easier to create this visualization in 2-dimensional space. In reality, it's much, much bigger. And I have a couple more examples. For example, I know many of you will disagree with it. Father minus man plus woman more or less equals mother. I know it's far from being perfect, but bear with me. The idea is that if the differences between 2 things are equal to differences between 2 other things, then we know their relations to each other. And also we can explain the parent concept in this way, like father minus man and mother minus woman are both parents. And this is a nice idea, but how do we use it? The humanity started a long time ago with Google started actually in 2013 with word2vec. Who knows about word2vec? Some of you. Okay, I probably need to explain a little bit. So it was the first major breakthrough into converting any words to vectors. It was huge because it actually was relatively fast and it was relatively small. Before that, we had all kinds of translators interpreting words one for each other, one after another. And here we gave the soulless machine a set of words, and it told us, here is how your words are located in multidimensional space. The basic idea is it predicts how words appear near each other. For example, as I said, cat and pet will be probably closer to each other than cat and rocket. And yes, cat and dog will often appear next to pet, food, vet, and so on. And it was a huge innovation because it was very fast to train. You don't need to put like years of training into this machine. It can be trained in hours or maybe days. And it produces very high quality embeddings. embeddings are just vectors, right? And it also showed that simple neural networks could capture complex meaning because it suddenly becomes obvious that it's just meanings is just statistics. What do we mean when we say cat? It's a pet, it has fur and so on, it needs fat. And people use it. And this is more than enough to build this meaning. And it changed the field of natural language processing because suddenly we didn't need to have some keywords to understand what's going on in our text. We could just build this huge multi-dimensional space which will describe each term in our book or whatever text we have. And it's still being used today. I will tell you more. These days, students in universities learn how to write their own Word2Vec, which is amazing. Well, again, back in 2013, it was a huge thing which Google had to invent. And it means they had a lot of big brains there. These days, this technology is so simple that anyone here literally can write their own Word2Vec implementation, and it will be not worse than what Google did. One important thing I forgot to say is each vector coming out of Word2Vec becomes a dense vector of numbers. Who knows what dense vector is? It's a vector where in which zeros are almost non-existent. It means almost every position in your vector has something non-zero value. And obviously, similar words have similar vectors, and vector math captures semantic relationship. Typically, Word2Vec will produce for each word from 100 to 300 dimensions, which is not that big, but we'll come back to this number a little bit later. And it enables mirror-towards similarity. It also has obvious limitations. First, the context window is very, very small. It only translates one word, right? And it means that if your word has polysemy, well, same word with different meanings, like Schloss and Schloss in German, for example, for lock and castle, and castle, it will lose it. It can't differentiate between them because it doesn't have any context to differentiate between them. And it requires pre-trained embeddings for each word. What it means that it should start somewhere. You should give it the first word, and then it will build all the statistics relative to this word. It's not important from which word you start, but you should start somewhere. It's not like there is non-trained Word2Vec. You give it some word, it produces vector, and you suddenly can use it in your system. No, then all the words should be converted to vectors with this particular Word2Vec instance, with this particular data. And there are modern alternatives to it, like BERT, but all of us know large language models because this is what we do. This is what we use these days with ChatGPT, Claude, and so on. What's important, modern models handle multiple word meanings. Otherwise, they would be almost useless. Now they distinct words with polysemy and so on. And the concept is essentially the same, but for Word2Vec it was cat, and it was transformed to a vector from 100 to 300 dimensions. Now the cat sat on the mat, and it's been transformed to a bigger vector. What is mind-blowing is now the similar texts get similar vectors. Do I have an explanation how it works here? I'm not sure, but we'll check. So, for me, it was very hard in school to say in the short words, I don't know, fairy tale or something like that. Large language models are exceptional in it. You can give it a paragraph of text and a paragraph of text in a different language, and it will somehow say that they are similar. Their vectors will be closed. And we all know the use cases, text classification, question answering, and so on. How it works for bigger models. First, it obviously splits the text into tokens. Then it processes through all these magical layers every token. We convert every token to vector. Then we capture relationships between the tokens. And this is an important part, which word2vec didn't have. Now we can say that cat is next to pet, and this means that they are related. Then it feed-forwards layers, transform data, and then they combine token representations somehow. Somehow is something in which we won't deep today, but it means we had, I don't know, 500 vectors, each from 100 to 300 dimensions. In the output of the LLM, we will have one vector with size, let's say, 1800 dimensions, which is almost magical. And it always outputs fixed sized vector, and size is obviously different for different models. Popular models are text embedding at the 002 for ChatGPT or for OpenAI. There is also SentenceBird, which is open source, universal sentence encoder, and so on. So it was a big talk about embeddings, but why do we need them? Why do we care about embeddings at all? And this was my next question to my friend. When I understood, at least to this level, embeddings, I was like, okay, why do I know this now? The thing is, every time we communicate with LLM or any, I don't know, ChatGPT, any AI, we actually use vectors on the hood. And again, similar text gets similar vectors, and they enable semantic search, which is crucial for RAG. The idea of RAG is very simple. We convert all the documents we need into embeddings and store these embeddings somewhere in a vector database. We'll talk about the vector database a little bit later. We convert user query to an embedding too. For example, you ask what is 2 by 2 from your ChatGPT, it's being converted to a vector. Then we find the most similar documents in our database. So obviously there are a lot of documents which answer the question about 2 by 2, right? We will find them and mix them into the prompt as a context of LLM, and then it will be able to answer it. This is not only a search, it's only a summarization. If you think about it, the document you can feed the LLM is insanely huge, and it's being summarized to like 1800 doubles. Every double by itself is not descriptive at all. When we look at doubles, we don't understand what it is. It's definitely smaller than word. It doesn't bring all the context of the word. And still somehow these complex embeddings are summarizations, which is just beautiful. And the next question which I asked my friend, but can't you just save our data in database and make ChatGPT to query this database? Because I didn't understand that the whole neural network thing, it's not even a program almost. There is a thin wrapper of running Python or whatever code. But essentially, neural network is a huge bunch of hard code. And I mean, by hard code, I mean hard-coded weights. There are special techniques that allow you to optimize the weights inside your model. And weights are it's just a huge linear equation which are being solved for each word. And hard-coded is a very important thing. There is no such thing as accessing something from neural network. Neural network is not a program, it's more of a data structure which somehow stores a lot of information. And yes, and here is the first time when I heard about RAG. And we already described the flow, just in case again. Convert our documents to embeddings, store them into a vector database, convert the user query into embedding, find most similar document embeddings, and feed these relevant documents into LLM as a context. Now, about the sizes of embeddings. I was saying about 1800, I was lying obviously. We can see that somehow all the popular models have different sizes of their vectors. For example, for OpenAI, it's 8191 token. For Mistral, it's 8,192 tokens, and I'm not sure what exactly stopped OpenAI from adding one more token just for the number to be beautiful. And for Claude, it's 8,000 tokens. Well, at least I like this idea that they're somewhat close. Why do we care about the context size? Because and the chunk size. Chunk is a piece of a document we feed into our LLM. Because if our chunk of document is too small when we are feeding it into an LLM, it loses some context. Like if it's one sentence, obviously it doesn't know anything about its paragraph. But if it's too large, like I don't know, Les Miserables, I guess if we will feed it the whole thing to LLM, it will lose a lot of meaning while creating an embedding for it, because it's impossible to summarize it in 8,000 dimensions. Now, the second part is store them in a vector database. I mentioned vector database couple of times already. Who knows what a vector database is? It's just a usual database, but it has some magic inside it. It supports several functions to, for example, compare vectors of doubles. And it is what's called similarity search. And there are multiple ways to do similarity search. There is a cosine similarity, Euclidean distance, dot product, and so on. They are supposed to be fast. Here's another example of how it can work. And who understands what's written here? Okay, nobody cares. I see. It's a dot product of two vectors divided by power of each vector, and power you can read as just length of of a vector. Let's see. Give me a sec. And it is cosinus phi, obviously. So imagine we have several entities. We have rose, we have sunflower, and we have sun. And you can imagine that sunflower is somewhat close to sun because, well, it needs sun and it has sun in its name. And we also have rose. And now when we look at the angle between each of these, each pairs of entities, we can see that for rose and sunflower, it's 19 degrees. Between sunflower and sun, it's 40 degrees. And between rose and sun, it's 60 degrees. So the similarity here is just a smaller cosine distance. The smaller cosine distance is, the more similar meanings are. This is that simple. The only issue is you should perform this calculation not in two-dimensional space, but in 800-dimensional space. But other than that, the idea is very, very simple. I could probably program it in, I don't know, an hour. The issue here would be it wouldn't work fast. So these folks in databases, in vector databases, just know how to write very efficient mathematical related code, how to operate on these doubles crazy fast. And there are many of these vector databases, and there is a new one almost every day. Chroma, VV8, Pinecone, Milvus, and pgvector. I like pgvector, and you probably will like it too, just because it's a PostgreSQL extension, sorry. Probably most of you use PostgreSQL, and this is why it will be crazy simple to implement vector to implement RAG in your own application. When you are looking from the end user standpoint, how will all this workflow work? Well, obviously, you need to somehow load the documents into your vector database. And let's call the user who can do it an administrator. You'll probably, if you have like knowledge base in your company, this is what you actually can do. Like feed it your whole wiki, split into reasonable sized chunks, and administrator can do it. They will download the documents, then it will feed every document to OpenAI or to some other model you can use. I don't know, it might be Mistral or something else. And for each document, they will get back embedding, and they will save embedding plus source text inside a vector database. This That simple. For queries, it's obviously more or less the same. The only thing, we don't need to save queries or vectors of queries into our database, depending on your user flow. Now, we need to find the similar documents embeddings. Usually, well, we use vector database for it because it has all the functions we need, and it usually returns several things. First, original text, because this is what we will use inside our LLM prompt. Optional metadata. Usually it's not optional, if I be honest with you, because usually you will need to at least save title of the document to tell people in which document this information was saved. Probably also extension of the document, date of its creation, how many chunks are there, and so on. And obviously, yes, distance and similarity score just to be able to sort it. We can limit number of results by this similarity score, and we can filter by metadata. For example, if this user is not allowed to look at documents with this part of metadata, we just filter them out in our SQL or whatever our database is, or whatever our database supports. Field relevant documents to LLM as a context. I will show it hopefully in the demo. The idea is we take the relevant documents from the vector search, their plain text representation, we add them as a context to LLM's prompt, then we asked LLM to answer us our question based on the provided context. LLM generates response using only provided context, and this is usually very important for us. We do not like LLMs be hallucinating for our data, for our documents. When I'm asking what garbage collectors are there in Java, I really don't need LLM to invent new garbage collector for me. I mean, I should be as precise as possible in this. And this gives us a more accurate and more grounded response in our documents. And from the user perspective, this is, if you're more of a diagram person, then this is how the diagram of user interaction with such a system works. They query our backend does a lot of magic, queries LLM, gets embeddings, queries vector database, and with top K, which stands for give me n most relevant documents, gets relevant documents as response, then it queries with relevant documents our LLM again, gets the answer, and sends the answer to user. So the whole complexity will be hidden from the user of your system. And in my case, from me. Now it's, whoa, too fast, sorry. Now it's a time for small demo. Who reads Kotlin here? Almost no one. Okay. So the whole demo is written in Spring, and I will explain to the best of my ability what's written here. First, I have the function store document, which should be obviously limited to only an administrator of our system, because no one should be able to upload documents if they are not allowed to. I don't have it here because it's just a simple demo. It stores document, so it receives multi-part file, and it calls a thing called unstructured. Let me show you. Please. Unstructured.io. So these guys, they build their system specifically to take your raw documents and convert them to a chunk of text with chunks of text with metadata, which are suitable to be processed by the LLM to create embeddings. And they support all kinds of things. And my very good friend, who doesn't pay me, works there and promotes this unstructured.io thingy. So they have trivial API. The trivial API, yes, something like this. The reason I used Kotlin is because I wanted to use Ktor HTTP client. It's essentially the only thing. So I make a request with the document which was sent to me by a user with a lot of arguments. Most of them are null by default, The only thing I'm interested is actually file. Well, there might be encoding, there might be multiple languages because there are multi-language documents. You can save a lot of metadata if you want. For example, here it allows you to keep XML tags. It asks you if you want to overlap your chunks of text, and if you want, sometimes it's useful to keep the context. Heavily depends on your particular document. In my case, I actually needed to overlap documents quite significantly, 30 symbols or something like that. Similarity threshold and so on. Then I just make this huge request, say, sending all the parameters to unstructured IO, and they return me. What do they return me? Get me back. They return me responses, which sends unstructured responses. It's just an alias for unstructured response. Unstructured response is a very simple class. It has type, it's just string. It has element ID, which is unique identifier of our piece of text, which is a useful part of metadata sometimes. Obviously text, which is a string of our chunk of the document. And then metadata. As I said, metadata can be a lot of things. For example, if we parse HTML pages, it can tell us which tag it was from which we parsed this thing. Then, when I did it, when I requested my thing with some data, maximal size of my chunking strategy, and so on, I need to map the response of unstructured to Spring internal entity. The whole project is implemented with Spring AI. So this unstructured response document adapter, thank you Java for big names, is a document. If we look at the document, it's a class from Spring AI, which contains ID. Do you remember UUID from our unstructured text? String, come on, text. If there are pictures or some other media, it can contain media. The most important thing here should be somewhere here, I believe. But can't see it at all. Come on. Okay. There was some metadata somewhere here, but I believe they changed something a little bit. Get me back. And I need to somehow convert my unstructured responses to Spring documents. This is what I do. I just create a document with ID equals name UID from bytes, text equals response text, metadata response metadata as map. As map is my own method which takes important stuff from metadata and puts it into a map. Important data for me is category depth, languages, file name, file type, parent ID, and is continuation. Is continuation, as you can imagine, is also an important part of context. Is this chunk of text is a beginning of a document or an end or somewhere in the middle? Is continuation kind of answers this question. Then I just, when I have my documents, I just save them to my vector store. And I love how simple this is. I mean, we do not think about embeddings here. We really need to dig deep into Spring AI to find our embeddings. For us, it's just documents with their text, which we add to vector store. All the magic happens externally. It converts each document to embedding. It saves it along with the actual data into a database. And then we say that, okay, it is done. The only other method in my controller is this query. This is obviously what users will use. So we take their query like this. Then we say that we want top 3 relevant documents to their query. And then we say vector store dot similarity search query. Again, all the magic is hidden here. All the embeddings are hidden. It's all the vectors, all the conversions. Spring AI knows by itself what model do we use to create embeddings. It says it converts user query to embeddings. It sends it to our vector store to find similar documents. Then I did something more or less, the only sophisticated thing in this talk. I said that I want to have this particular format of each document you put inside my vector database. I want to have title in big letters and then file name in there, and we take file name from the metadata. And I also need this caps locked body and text of this body after this text. And I have these crazy separators here, just to be sure that LLM actually understands that it wasn't part of a document. It is my thing which I put in between documents. I have this prompt. I don't know. I think it's nothing interesting. I just describe my format to LLM. I say that here's how my delimiter looks. If you don't know answer, please say, sorry, I don't have such information. Use the following information, and here I will interpolate information actually which is coming from our users. Whoa. Found a bug here spontaneously. Then we have all the boring stuff. We create prompt template, we create user message, we create prompt. Now, then we have our chat client. We prompt it with prompt. We call it, we get content from it. And this is our response, which we will return to our user. Let's try it. Hopefully it will work. And hopefully it will build. I mean, Gradle, right? You can never be sure. It runs, which is a good sign. Oops, it doesn't run, which is a bad sign. Connection refused for real. Oh, right. I should bring up my vector database, I guess, for it to work. Please. And runs. Nice. Okay, I have a couple of documents here. They are actually JEPs. JEP 505, which is structured concurrency. Who knows this JEP? Okay. It's an interesting JEP. We'll ask some questions about it. Essentially makes Java closer to Kotlin. Now we can have nice things in Java. We have very nice syntax of scoping our tasks, which can be cancelled and so on. Let's feed it to our system. Takes some time, and internet here is not as fast as it could be. Nice. I have another one here too. 402, another JEP. Enhanced primitive boxing, which is not as interesting, but I just need to feed something into my system. Let's see how it works. Well, while it's thinking, hopefully someday we'll have enhanced primitive boxing in Java. It is there. Let's look at our database. Refresh. Yes, Spring automatically creates this vector store table. My super secret password is password, by the way. You can see all these IDs here. We have them from unstructured.io. We have this content, which is a raw content of our JEPs, split into chunks. And we can see here that there are 5 documents with created from JEP 505 and only 2 from 402, which is logical. JEP 402 is significantly smaller. Let's now try to ask something smart from our system. Did I lose my request? Scratches. Oh, I already have a prepared question. Nice. I'm not sure if our internet's fast enough, but give me the code to run 2 tasks in the structured task scope. This is actually it's nice. Let's try to make it bigger. Or can't I? Here's an example code snippet that demonstrates, blah, 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 and it gives us actually a slightly different code than we had in our JEP. So it found somehow relevant documents in our database and so on. Well, and I mean, the call code, if you look at it, kind of makes sense in the future syntax. Let's ask a different thing. What's my name? And hopefully it won't answer, but we should be sure. Yeah, sorry, I don't have such information. And this is exactly what we want to see when we query our smart LLM about our documents. We don't want to see hallucinations, nothing like that. We want exact answers or exact knowledge that, sorry, I don't know. One more thing I should say, I use here unstructured.io as an example to create documents, but actually Spring has its own support for custom documents. It's called Ticker Document Reader. It's a separate Spring Boot starter. And it's also very simple. You just create Ticker Document Reader from input stream resource, in my case, file input stream. This is essentially all. It won't create all the nice metadata for you, but it's perfectly functional. So if you need full text search-like functionality, then probably Ticker Document Reader is your way. But if you need to process documents in a bulk and have a lot of metadata to them, then you should probably go with unstructured.io. Now, we don't have much time remaining. Let me switch back to the presentation. Small summary. First, RAG is simple, especially when everything is written for us, like in Spring AI. You need to know embeddings to understand RAG somehow, because otherwise it's just a black box with magic, like on my third slide. And I don't like black boxes. I don't know about you. Embeddings are not magic, they're just vectors, and vectors are just arrays of doubles. And you actually don't need to know how LLM works to use RAG, which is a beautiful thing. Thank you so much. Code and blog post about this content are on our site. You can find them by QR codes, and you can follow me. We have Thank you. We have 3 minutes for questions.
This may be a tricky one, but in terms of equivalency between your question and the documents that are being checked, do you have an extra step that enables you to create, like in Perplexity or others, you will have a query fan out where you query something and it like completes the query, tries to understand it better. Do you do that? Do you create a document that can be like matching basically what's going on, or
Currently, I do not, but it's very simple. This flow, if necessary, is very simple to implement with Spring AI. Like this, it's almost like chatting, right?
Yes.
You force your LLM to ask you questions before they will give you actual answers. It is possible. Your system prompt will be slightly more complex, obviously. You will ask it first, ask me some questions, then we will look for documents and so on.
Okay.
But other than that, it is very simple to implement with Spring.
Thank you.
Thank you for the question. I saw a question. Yeah.
Thank you for the presentation. I was one question for the searching. Did you try the hybrid searches in RAG? If yes,
Sorry, which?
hybrid, meaning that you build a template of the results that you look like, and then you pass the templates with the query, so that it will find the nearest template in the documents. For example, if you're searching for a back statement, then you create a template of back statement and you pass it to the LLM as well.
It sounds beautiful, and I think that Melee search have something very similar. You can push a query into it, and it will try to first do trivial full-text search, and if that doesn't work, it will fall back to an AI-backed search with embeddings, comparisons, and so on. It is obviously more costly. I myself didn't do anything like that, but Melee search has a, in my opinion, very close feature. Thank you. Thank you for the question. Please.
Yes, thanks for the talk and the demo. How do you make sure that the LLM sticks to the responses you have from the vector database? What if it will like just respond from its memory?
So you saw the example here. I asked it something, and it told me very upfront that I don't know an answer. We can also force LLM to give us, for example, links to sources. It's when we control the system and we have links, it's very, very simple to do actually. For example, we save every document somewhere, and then we can check. Is there automated testing to verify that LLM never hallucinates? I'm not aware of such a thing. You can try to do some quality testing like they use for search engines when they know what results should come out for some particular inputs. But we should also be, if it's an external LLM which you don't control, then results can be slightly different. And you because we don't control temperature essentially, it is not fully determinate. So you can try to control it with temperature set to 0 if it's an LLM that you host at your company or somewhere. Then you can be fully determined.
So time is off.
Thank you so much.
Thank you.